Hello everyone and welcome to this channel Lucid Mind Chemistry with Majid. In this video I'll be discussing Chemistry A-Levels Multiple Choice Paper 12 October-November 2019. You can skip to any question by following timestamps given in the video description. Feel free to give any comments, likes and shares to this video. Also you can subscribe for more upcoming videos. Let's start solving. Question number 1. The diagram shows a Boltzmann distribution of the energies of gaseous molecules and activation energy of a reaction with and without a catalyst. This is the diagram. On y-axis we have proportion of molecules with energy E. On x-axis we have two activation energies. One is activation energy 1 and second is the activation energy 2. Which statement about this distribution curve is correct? A. If the temperature of the gas is increased, the maximum of the curve becomes higher. As we know that in Boltzmann distribution of energies, the area under the curve always remains constant. So therefore, whenever temperature is increased, the average molecular energy increases. So this hump will come downwards and this will go upwards. At higher temperature, the graph would be like this. So this is incorrect. B. If the temperature of the gas is increased, the maximum of the curve moves to the left. As we have seen in this diagram that the curve has moved a little bit towards the right side on increasing the temperature. When the temperature is decreased, then the curve will move to the left side and the hump will become higher like this. So B is also incorrect. C. The fraction of molecules that react in the presence of a catalyst is shown by these lines. Let's look into the diagram. We have EA2 and EA1. Now we know that whenever a catalyst is added, the activation energy is reduced. So therefore EA1 is with catalyst. And EA2 is the activation energy without catalyst. Now we can see in the diagram that without catalyst, this much number of molecules can convert into products easily. But when the catalyst is added, then the activation energy is reduced and now this much molecules will be converted into product. So therefore with catalyst, it is not just this one. Actually both of them will be converted into product. So it should be this and these both. So therefore option C is also incorrect. In D, the fraction of molecules that react in the absence of catalyst is shown by this one. Yes, this one was without catalyst, so D is correct option. So therefore answer is D. Question 2. In this question it should be assumed that ammonium carbonate H2O solid dissolves in water without causing an increase in volume. Which mass of ammonium carbonate H2O should be added to 800 cm³ of water to form a 0.100 mole per decimeter cube solution of ammonium ions? In the question they have given the volume, which is 800 cm³ and concentration of ammonium ions, and we have to find the mass. Let's first find the number of moles from these values. The formula for number of moles is equal to N will be equal to concentration in mole per decimeter cube into volume in decimeter cube. So putting values from the question, we have 0.1 mole per decimeter cube concentration of ammonium ions and the volume is 800 cm³. Let's just convert it into decimeter cube. We divide it by 1000. So the answer is N is equal to 0.08 moles of ammonium ion. Now let's write a balanced chemical equation for the dissolution of ammonium carbonate H2O in water. We can write the equation as this: ammonium carbonate dot H2O dissolves in water to give ammonium ions and carbonate ions. So in order to balance, we have 2 moles of ammonium ions produced from 1 mole of ammonium carbonate dot H2O solid. So the molar ratio from the balanced equation is 1 mole of ammonium carbonate dot H2O dissolves to form 2 moles of NH4 positive. Now in the question, as we have 0.08 moles of ammonium ions, so we can write 0.08 moles of ammonium ions will give X moles of ammonium carbonate. Let's just cross multiply. So we can have 2X is equal to 0.08 or X is equal to 0.04 moles of ammonium carbonate dot H2O. In the question, they have asked about the mass of ammonium carbonate that should be added, so therefore we need to convert these moles into mass in grams. As the molecular mass of ammonium carbonate dot H2O is 114, so therefore we can use the formula mass in grams is equal to moles into mR. So we have 0.04 moles into 114. So it comes equal to 4.56 grams of ammonium carbonate dot H2O. So therefore answer is A. Question 3. The graph shows the successive ionization energies of element X and element Y. Both elements are in period 3 of the periodic table. Which statement is correct? We can see in the graph that the line represents element Y and dotted line represents element X. So this is element Y. And this one is element X. Let's move towards the statement A. An atom of element X needs 1 extra electron for full outer shell. An atom of element Y needs 3 extra electrons for full outer shell. Now we can find out whether this statement is true or not by finding out the group number of element Y and element X. Now we can see that the ionization energies between 5th ionization energy and 6th ionization energy, the element Y makes a jump, so it means that the shell is removed after 5th electron and the 6th electron is in the inner shell that is nearer to the nucleus, so therefore larger amount of energy is required to remove 6th electron as compared to 5th electron. So we can say that element Y belongs to group 5 of the periodic table. Similarly, for dotted line, we can see that in element X, the jump is from 7th ionization energy to 8th ionization energy. So it means that the shell is changed when we move from 7th electron to 8th electron. So therefore there are 7 electrons in the outer shell. So it could be from group 7 of the periodic table. So element Y is from group 5. And element X is from group 7 in the periodic table. So therefore element X has 7 electrons in the outermost shell and in order to complete the octet it just needs 1 electron. While element Y is in group 5, so it has 5 electrons in the outermost shell and in order to complete the octet it will need 3 more electrons. So this is in correspondence with statement A, so therefore statement A seems to be true. B. An atom of element Y has 5 electrons in 3p subshell. Let's find out what is element Y. So according to the periodic table, the element that is present in group 5 and period 3 of the periodic table is phosphorus. The atomic number of phosphorus is 15, so it will be 1s2, 2s2, 2p6, 3s2, 3px, 3py, 3pz, and each p orbital has one electron. So we can see that there are just 3 electrons present in the p orbitals of phosphorus. So this is incorrect. C. An element X has an oxidation number of +7 in most of its compounds. According to periodic table, element X belongs to group 7 and period 3 of the periodic table, so therefore element X is chlorine. So we know that in most compounds chlorine has -1 oxidation state. So therefore C is also incorrect. D. When element X combines with an element Y, the bonding is ionic. As we know, one is phosphorus, second is chlorine. So the bonding between two nonmetals is not ionic, it is actually covalent. So they will share electron and form PCl3 or PCl5. So this is also incorrect. So the only correct option is A. Question 4. Which statement about the electrons in a ground state carbon atom is correct? Ground state is the normal state of carbon. The atomic number of carbon is 6. So the electronic configuration is 1s2, 2s2, and in 2p there are 2 electrons. One is in 2px and the second one is in 2py orbital. Moving towards the statements, we have A. Electrons are present in 4 different energy levels. As we can see, there are 3 different energy levels. One is 1s, second is 2s, and third is 2p. So it is incorrect. B. There are more electrons in p orbitals than there are in s orbitals. As we can see that 2 electrons are present in p orbital and 2 electrons are present in each s orbital. So therefore this is also incorrect. C. The occupied orbital of highest energy is spherical. Now the occupied orbital of highest energy is p and the shape of p is dumbbell. It is s orbital which is spherical in shape. So therefore this is also incorrect. D. The occupied orbital of lowest energy is spherical. As we can see that the lowest energy is 1s and s is spherical in shape. So D is correct. Therefore answer is D. Question 5. In this question you should assume the vapor behaves as an ideal gas. 0.175 grams of volatile liquid produces a vapor of volume 4.5 exponential minus 3 meter cube at 100 degrees centigrade and a pressure of 1.013 exponential 5 pascals. What is the MR of the liquid? Let's simply write ideal gas equation. We have PV is equal to nRT, where P is the pressure, V is the volume, N is the number of moles, R is ideal gas constant, and T is temperature. As we know that number of moles is equal to mass divided by molecular mass, so PV will be equal to mass in grams divided by MR into R and T. As we have to find MR of the liquid, so we can write MR will be equal to mass into R into T divided by pressure into volume. Now we can put the values. MR will be equal to mass is 0.175 grams. Ideal gas constant is 8.314 pascals meter cube per Kelvin per mole. Temperature is given in degrees centigrade, so we have to convert it into Kelvin by adding 273. It will become 373 Kelvin. So into 373 Kelvin. Divided by pressure given is 1.013 exponential 5 pascals. Volume given is 4.5 exponential minus 5 meter cube. This will cut out pascals with pascals, Kelvin with Kelvin, meter cube with meter cube. So the value of Mr comes equal to 119 grams per mole. So therefore answer is C. Question 6. Which reaction is endothermic? A. Calcium hydroxide reacts with HCl to form salt and water. As we know that calcium hydroxide behaves as a base and HCl is acid, and the reaction between acid and base to form salt and water is called neutralization. And neutralization is exothermic in nature. So therefore this is incorrect. In B we can see that the chlorine atom converts into chlorine molecule. Now the atoms are in high energy state and they make a bond and it becomes a molecule in low energy state. So the formation of bond is always exothermic in nature. So this is also incorrect. In C we can see calcium reacts with oxygen to form calcium oxide. This is a combustion reaction. So the combustion reaction is also exothermic in nature. So this is also incorrect. In D we have calcium carbonate which is in solid form and it is decomposed into calcium oxide and carbon dioxide. Decomposition needs energy, so therefore this is endothermic reaction. So therefore option D is the correct one. Question 7. Which equation correctly represents the standard enthalpy change of atomization of the given element? Now you have to remember the definition of enthalpy change of atomization. In this what happens that 1 mole of gaseous atoms are formed from elements in standard states. Now we can see in A we have 1 mole of product, in B we have 1 mole of product, in C we have 2 moles, so therefore C is incorrect. In D we have 1 mole of ionic product. In A we have iodine which is in gaseous state. Now iodine is normally in solid state, it is not gaseous. So A is incorrect. In B we have sodium solid which converts into sodium atom. So this could be correct. In D we can see sodium atom is converted into sodium ion. So therefore this is ionization energy. So D is also incorrect. The correct option is B. Question 8. Ammonium chromate decomposes when heated. The products are nitrogen, water and chromium trioxide. Which element is oxidized and which element is reduced? Let's find the oxidation states of these elements. Now we know that nitrogen is in molecular form, so therefore oxidation state of nitrogen here is 0. In water, hydrogen is always +1 and oxygen is -2. In Cr2O3 we have 2 chromium atoms and 3 oxygen atoms and the overall charge is 0. So we can write 2 Cr plus 3 oxygen equals to 0. As we know that the oxidation state of oxygen is -2, so for 3 oxygen the charge will be -6. So 2 Cr is equal to +6 or 1 Cr will be equal to +3. So we can write +3 for 1 chromium and -2 for 1 oxygen. Let's find the oxidation state of nitrogen in ammonium first. As we know that the charge on ammonium ion is equal to +1. Now nitrogen is more electronegative than hydrogen, so therefore we have 1 nitrogen and 4 hydrogen atoms. And the oxidation state of hydrogen will be +1, so we have 4 hydrogen atom, it will be equal to +4. And nitrogen will become -4 + 1, which equals -3. So we can write -3 for nitrogen plus 1 for hydrogen. Now let's find the oxidation state of chromium and oxygen. We have NH4 2 Cr2O7 and the overall charge is 0. So we have 2 ammonium ions, 2 chromium atoms, 7 oxygen atoms, and the overall charge is 0. As we know that the charge on ammonium ion is +1, there are 2 ammonium ions, so it will be +2 chromium. And the oxidation state of 1 oxygen is -2, so for 7 oxygen atoms it will be -14. So we can write 2 chromium, -12 is equal to 0, or 2 chromium is equal to +12, and on 1 chromium it will be +6. So +6 for chromium and -2 for oxygen. So we can see that nitrogen goes from -3 to 0, so it is oxidation, while chromium goes from +6 to +3, so it is reduction. The oxidation state of hydrogen remains same and of oxygen also remains same in the reactant and product. So we can see nitrogen is oxidized and chromium is reduced, so therefore answer is C. Question 9. When lead 2 sulfide PbS is heated in air, sulfur dioxide and lead 2 oxide are formed. What is the equation for the reaction between lead sulfide and oxygen? So we can see sulfur dioxide and lead 2 oxide are formed. The formula of sulfur dioxide is SO2, and on lead 2 oxide we have +2 charge on lead and -2 charge on oxygen, so it will be PbO. So in the first one they have given PbO2, so it is incorrect. In the second one it is also PbO2. In the third one it is PbO and SO2, so this could be the correct option. And in D you can see SO3 and PbO, so therefore it is incorrect. So the only correct option is C. Question 10. The decomposition of sulfur trioxide gas is a dynamic equilibrium. Sulfur trioxide gas converts into sulfur dioxide gas along with oxygen gas. What happens when the pressure of the system is increased? As we know that in gases, what happens when we increase the pressure, the molecules come close together and there are more effective collisions. And the rate of reaction also increases. Let's talk about the position of equilibrium. We have 2 moles of the reactants and we have 2 + 1 moles of products. So whenever pressure is increased, the gaseous equilibrium reaction moves from more number of moles to less number of moles. So therefore by increase in pressure, the equilibrium will move towards the left side. Let's move towards the option A. The rate of reaction will decrease and the position of equilibrium will move to the left. As the rate of reaction will increase, so therefore this is incorrect. In B, the rate of reaction will decrease. Again, this shows a decrease, so therefore this is also incorrect. In C, the rate of reaction will increase. This is true. And the position of equilibrium will move to the left. As we know, it will move from more number of moles to less number of moles, so it is to the left. So C seems correct. Indeed, the rate of reaction will increase and the position of equilibrium will move to the right. So this is incorrect. So the only correct option is C. Question 11. Hydrated aluminum ions undergo the following chemical reaction. Which statement about this reaction is correct? H2O liquid and AlH2O5OH+2 aqueous are conjugate acid-base pair. Now two things are acid-base pair only when they differ by H positive. For example, we can say that H2O liquid and H3O positive are acid-base pair, as the difference is only of H positive ion. As in H2O liquid and this compound, there is a difference of more than one H plus ion, so therefore this is not a conjugate acid-base pair. B. H2O liquid is acting as an acid as it is donating H positive ions. As in the chemical reaction, we can see that H2O liquid converts into H3O positive aqueous. So whenever H2O liquid converts into H3O positive aqueous, it means it is gaining H positive ion. So H2O is actually accepting H plus, so therefore H2O is not an acid, it will behave as a base. So this is also incorrect. Part C, if OH negative aqueous is added, the equilibrium will move to the right. As OH negative is basic in nature, so therefore what will happen that OH negative will react with H3O positive in a neutralization reaction and it will form H2O. So the concentration of H3O positive will decrease, and as H3O positive is the product, so therefore the decrease in the amount of product makes the reaction go in the forward direction. So the equilibrium will move to the right. This is correct. D. Kc varies as the pH is varied. Kc represents the equilibrium constant expression, and we know that Kc only changes with the change in temperature. And it is not affected by pH or pressure or concentration. So therefore correct option is C. Question number 12. Which diagram correctly shows the electronegativity of the elements sodium, magnesium, aluminum and silicon plotted against their first ionization energies? First thing is electronegativity. Now electronegativity is the tendency of an atom to attract a shared pair of electrons towards itself in a covalent bond, and we know that electronegativity increases with increase in nuclear charge. So therefore in moving across the period, what happens that the electronegativity will increase as the nuclear charge increases but the number of shells remain constant. So therefore electronegativity increases with having small size and large nuclear charge. The atomic number of sodium is 11, magnesium is 12, aluminum is 13 and silicon is 14, and they are consecutive members of period 3. Second thing is first ionization energies, and first ionization energy is the removal of first electron from isolated gaseous atom. Along the period, the general trend is that ionization energy also increases as the size of an atom decreases, and therefore there is more attraction between the outer electron and the nucleus, and also the nuclear charge has been increased, so therefore ionization energy will increase across the period. Now looking at the electronegativity trend, we have sodium, then magnesium, then aluminum and then silicon. So the electronegativity trend is correct. Looking at option B, we have sodium, then magnesium, then aluminum, then silicon. So the electronegativity trend is correct in both A and B. In C, we can see that the sodium is most electronegative, so therefore this is incorrect. In D, again sodium is made more electronegative, so it is incorrect. So let's find the correct option in A and B. The only difference in A and B is the ionization energy of magnesium and aluminum. Let's find out which is the correct one. Let's do the electronic configuration. Magnesium is 12, so it has 1s2, 2s2, 2p6, 3s2. And the atomic number of aluminum is 13, so it will be 1s2, 2s2, 2p6, 3s2, 3p1. So 1 electron is removed from 3s in case of magnesium and 1 electron is removed from 3p in case of aluminum. As 3p is further away from the nucleus as compared to 3s, so therefore less energy will be required in case of aluminum, so the ionization energy of aluminum should be less than magnesium. So we can see that option B shows this trend, so therefore answer is B. Question 13, which statement about the compounds of group 2 elements magnesium to barium is correct? A. Carbonates of group 2 elements produce bubbles when added to dilute nitric acid. We know that all group 2 carbonates produce salt, water and carbon dioxide in the presence of dilute acid. As carbon dioxide is in gaseous state, so therefore bubbles will be produced. For example, if we have calcium carbonate, it will react with dilute nitric acid. It will form calcium nitrate along with water and carbon dioxide. So option A is correct. In B, it says nitrates of group 2 elements produce nitrogen and oxygen on heating. As we know that all group 2 nitrates in the presence of heat they decompose and form metal oxide along with nitrogen dioxide and oxygen gas. For example, if we have calcium nitrate, upon heating it will produce calcium oxide, NO2 and oxygen gas. In the question they have given nitrogen, so therefore nitrogen is incorrect. So option B is wrong. Option C, oxides of group 2 elements produce bubbles when added to dilute hydrochloric acid. We can say that group 2 oxides are actually metal oxides, so therefore they are basic in nature and they will react with HCl to form salt and water. So as no gas is being produced, so therefore no bubbles will be seen. For example, if we have calcium oxide, it will react with dilute HCl to form calcium chloride along with H2O. Calcium chloride is aqueous and water is in liquid state. So option C is also incorrect. In D, it says the oxides of group 2 elements are amphoteric in nature. As we know that group 2 elements are metals and the oxides of metals are basic in nature. So therefore this is also incorrect. So the correct option is A. Question 14. When equal volumes of saturated solutions of barium hydroxide and calcium hydroxide are mixed, a white precipitate Y forms. The mixture is filtered and carbon dioxide is bubbled through the filtrate, producing a second white precipitate Z. What are Y and Z? As we know that in group 2 hydroxides, what happens that as we move down in the group, the solubility increases. So therefore we can say that calcium hydroxide is less soluble than barium hydroxide. So when barium hydroxide and calcium hydroxide are mixed with each other, what happens that the solubility of barium oxide will be high and calcium hydroxide will become a precipitate. So precipitate Y is calcium hydroxide. And the filtrate will be barium hydroxide. So as carbon dioxide is bubbled through the filtrate, we can write the chemical equation. CO2 will react with barium hydroxide and it will form barium carbonate along with H2O. Barium carbonate is insoluble, so therefore it is in the form of precipitate. So precipitate Z will be BaCO3. So Y is calcium hydroxide and Z is barium carbonate. So the answer is C. Question 15. Chlorate ions ClO3 negative are produced in the redox reaction between chlorine and hot aqueous sodium hydroxide. Oxidation numbers can be used to help balance the equation for this reaction. What are the values of V, X and Y? So V is Cl2, X is Cl negative and Y is ClO3 negative in the balanced equation. Let's first find out the oxidation state. Cl2 is in the molecular form, so therefore oxidation state is 0. In Cl it is given as -1. In ClO3 it will be like this. We have 1 Cl and 3 oxygen atoms and overall charge is -1. So the oxidation state of 1 oxygen is -2. So for 3 it will be -6 and Cl will become +5. So it is +5 in ClO3. We have to find values of V Cl2, X Cl negative and Y ClO3 negative. Let's write the oxidation reduction equations. So in first reaction, chlorine gas converts into chloride ion upon reduction. We can balance number of atoms as there is only one atom on product side, so we can write 1/2 on the reactant side, so it would be balanced. As half chlorine will gain 1 electron in order to form chloride ion. Therefore, I wrote 1 electron on the reactant side. Second equation is the oxidation from Cl2 to ClO3 negative, so we can write Cl2, ClO3 negative. Again, in order to balance the number of chlorine atoms, we have 1 chlorine atom in the product, so I can write 1/2 with the reactants. As the oxidation state of Cl in the product is +5, so 0 into +5 means 5 electrons are lost by chlorine, so I can write +5 electrons. The first reaction is reduction and second reaction is oxidation. As we know that in balanced equation, the number of electrons lost must be equal to the number of electrons gained. So we can balance these number of electrons by multiplying this equation with 5. So rewriting the first reduction equation, now I have Cl2, Cl negative. 5 is multiplied by 1/2, so it will become 5/2 for chlorine. The number of electrons will become 5. The number of chloride ions will also become 5. Now combining both of these equations together, I can write 1/2 plus 5/2 will become 6/2 Cl2. Electrons lost and gained will be cancelled out. The product formed will be Cl negative and ClO3 negative, and with Cl negative there will be 5 moles. Instead of 6/2 I can write 3, so V will become 3, X is equal to 5 moles and Y will be equal to 1 mole. So the correct option for V is 3, for X is 5 and Y is 1, so therefore answer is C. Question 16. The properties of chlorine, bromine and their compounds are compared. Which property is smaller for chlorine than for bromine. A is the bond strength of hydrogen halide bond. As we know that chlorine is more electronegative than bromine, so therefore the bond in HCl is stronger as compared to the bond in HBr. So this is incorrect. Second is the first ionization energy. Ionization energy is the removal of electron from the outermost shell of an isolated gaseous atom. As we know that chlorine is above in the group as compared to bromine, so therefore atomic size of chlorine is less than bromine, so it will be easier to remove an electron from bromine rather than from chlorine. So the ionization energy of chlorine will be higher than for bromine, so therefore B is also incorrect. C is the solubility of silver halide in NH3. As we can see that AgCl is more soluble in NH3 than AgBr. So AgBr does not dissolve in aqueous ammonia. So C is also incorrect. In D it says strength of van der Waals forces between molecules of the element. As we know that van der Waals forces increase with increase in size of atom. So therefore bromine is a larger molecule as compared to chlorine. So therefore van der Waals forces in bromine molecules will be greater than among chlorine molecules. So van der Waals is the only property that is greater in bromine as compared to chlorine. Question 17. Solid sodium iodide reacts with concentrated sulfuric acid to form more than one product that contains sulfur. What is the lowest oxidation number of sulfur in these products? Now sodium iodide reacts with sulfuric acid in a series of chemical reactions. We can write them like this. Sodium iodide with sulfuric acid, it will first form sodium hydrogen sulfate along with hydrogen iodide gas. Hydrogen iodide will again react with sulfuric acid to form iodine, sulfur dioxide and water. Also Hi can react with sulfuric acid to give iodine, sulfur and water. Now hydrogen iodide can also react with sulfuric acid to form iodine, hydrogen sulfide and water. Now the sulfur compounds in these products are sodium hydrogen sulfate, sulfur dioxide, sulfur itself and hydrogen sulfide. Let's find the oxidation number of sulfur in these compounds. We have NaHSO4. The overall charge is 0. We have 1 sodium, 1 hydrogen, 1 sulfur and 4 oxygen. So we can write Na plus hydrogen plus sulfur plus 4 oxygen will be equal to 0. Now putting oxidation numbers, plus 1 is for sodium, plus 1 is for hydrogen. For sulfur we have to find out. For 4 oxygen it will be -8. So the oxidation state of sulfur will be +6 in sodium hydrogen sulfate. In SO2 the overall charge is 0. We have 2 oxygen atoms. So therefore it will be -4 for 2 oxygen and the oxidation state of sulfur is +4 in SO2. For third one we have sulfur solid. as it is an element, so therefore oxidation state will be 0. The fourth one is hydrogen sulfide. Overall charge is 0. We have 2 hydrogen atoms and 1 sulfur. Overall charge is 0. So for 2 hydrogen we would have +2 and sulfur will become -2. So we can see that the lowest oxidation number of sulfur in these compounds is -2. So therefore answer is A. Question 18. Which emission from an internal combustion engine contributes to the erosion of marble statues? As we know that marble statues are made up of calcium carbonate, and calcium carbonate is eroded by acid to form calcium oxide and carbon dioxide. Let's find out the options. In A we have carbon monoxide, as it is a neutral oxide, so it does not have any effect on calcium carbonate. B is nitrogen. Nitrogen is also neutral. C is nitrogen dioxide. It is an acidic gas, as it dissolves in water to form HNO2 and HNO3. D is unburnt hydrocarbons, which are also neutral in nature. So the only correct option is C. Question 19. Ammonia, carbon dioxide and water react together to form ammonium carbonate. Which statement about this reaction is correct? Let's first write the chemical equation. We have ammonia, carbon dioxide and water. Ammonium carbonate is formed. A. It is a redox reaction. Let's find the oxidation states. In ammonia, nitrogen is more electronegative, so the oxidation state of nitrogen is -3. For one hydrogen it will be +1. For carbon it will be +4, and for a single oxygen atom it will be -2. For one hydrogen it will be +1, for one oxygen it is -2. Again, in ammonium ion, nitrogen is more electronegative, so it is -3 for nitrogen, +1 for hydrogen, -2 for one oxygen and +4 for one carbon atom. As we can see that no change in oxidation state has occurred in the reactants and products, so therefore it is not a redox reaction. B. It is an acid-base reaction. As we can see that in this reaction, ammonia is in NH3 form and in product it is in NH4 positive form. So actually NH3 will react with water and it will gain a proton from water to form NH4 positive. So water will donate its H positive to NH3, so therefore water behaves as acid and ammonia will behave as a base. So B is the correct option. In C, the H and H bond angle decreases as a consequence of this reaction. We have two nitrogen compounds, one is NH3. In NH3 there are 3 hydrogen atoms and one lone pair of electrons, and the bond angle is 107 degrees. In ammonium ion we have 3 hydrogen atoms covalently bonded with nitrogen, and fourth hydrogen is making a coordinate covalent bond with nitrogen, and the overall charge is +1. As there are 4 bonds, so the bond angle will be 109.5. As the bond angle has increased, so therefore statement C is wrong. D. The 3 substances react in a 1:1:1 ratio in this reaction. As we can see that 2 moles of NH3 react with 1 mole of carbon dioxide and 1 mole of water. So therefore this is incorrect. So the only correct option is B. Question 20. Structural isomerism and stereoisomerism should be considered when answering this question. How many isomers with the formula C5H10 have structures that involve pi bonding? Stereoisomerism could be cis-trans or optical. C5H10 is an alkene as it has 5 carbons and 10 hydrogens, so it is a pentene. Let's draw possible structures of pentene. We have 1, 2, 3, 4, 5. And the double bond could be between first and second carbon, so it is pent 1-ene. If the double bond is between second and third carbon, then it will become pent 2-ene. Now looking at the cis-trans isomerism, we have pent 1-ene, and in this one the double bonded carbon is making bonds with 2 hydrogen atoms. As both atoms are similar, so therefore pent 1-ene cannot show cis-trans isomerism. In pent 2-ene we can see that the double bonded carbon is making one bond with hydrogen atom and other bond with CH3, while the other double bonded carbon is making one bond with hydrogen and second bond with ethyl. So as both groups attached are different, so therefore pent 2-ene can show cis-trans isomerism. So it could be cis pent 2-ene or trans pent 2-ene. Another possible structure that we can draw is the one in which double bond is between first and second carbon, and there are 4 carbons in the long chain, while the methyl group is attached with the second carbon atom. So it will be 2-methyl but 1-ene. We can change the structure like this. The methyl group could be attached with the third carbon atom, so the name will become 3-methyl but 1-ene. Another possible structure is this one, in which double bond is between second and third carbon atom and methyl group is attached to the second carbon, so the name will be 2-methyl but 2-ene. Now we can see that neither of these structure has any chiral carbon present, so therefore there will be no optical isomerism. Now the number of isomers are pent 1-ene, cis pent 2-ene, trans pent 2-ene, 2-methyl but 1-ene, 3-methyl but 1-ene, and 2-methyl but 2-ene. So 6 possible isomers are having double bond. Question 21. The diagram shows the skeletal formula of phenazine. This is the skeletal formula. What is the empirical formula of phenazine? Let's count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 carbon atoms. Now let's find out the number of hydrogens. This carbon is making 3 bonds, so one is hydrogen. One is with this carbon, one is with this, one with this. As this carbon is making 4 bonds, so therefore no hydrogen will be present. Similarly, no hydrogen is for this carbon and for this carbon and for this carbon. One hydrogen atom will be present with these carbon atoms. So in total we have 8 hydrogens and 2 nitrogen atoms. The empirical formula is the simple ratio, so it will be C6H4N. So therefore answer is A. Question 22. An organic compound X reacts with hot concentrated acidified potassium manganate to give a single carbon containing product. what could be X? You should know that hot concentrated acidified potassium manganate breaks double bond completely. And different types of products are formed based on the reactant involved. Let's look at the options. In A we have CH2, carbon, and then two methyl groups are attached with the second carbon atom. So A will be like this. There is a double bond present between first and second carbons. Now when this compound is reacted with hot concentrated acidified potassium manganate, what happens that this double bond will break completely and two different products are formed. This carbon will make CO2 and this carbon will be converted into a ketone. In B we have CH3, CH, CH3, so there is a double bond between second and third carbons. Let's draw the structure of B. Again the double bond will be broken completely, and as both sides of this double bond are symmetric, so we would have 2 moles of CH3, C double bond OH, so it is an aldehyde. In C we have CH2, CH, CH2, CH3, so the structure will be like this. Again on oxidation this double bond is broken and two different products are formed. The first carbon will convert into a carbon dioxide and second will convert into aldehyde. In D we have CH3, CH2, CH2, CH3. So therefore this is an alkane and there is no double bond present. The structure will be like this. And in the presence of hot concentrated acidified potassium manganate, oxidation will not occur. So B is the only organic compound that gives single carbon containing product. Question 23. 1-chloro-2-methylbutane reacts with sodium cyanide in ethanol in a nucleophilic substitution reaction. What is most likely intermediate or transition state in this reaction? We have 1-chloro-2-methylbutane, so we can draw the structure. Chlorine will be on first carbon, methyl will be on second carbon. As it reacts with sodium cyanide, so we have nucleophile as cyanide. As chlorine is more electronegative than carbon, so therefore carbon will become partial positive and chlorine will become partial negative. And this will attack on this carbon atom and this bond will be broken and Cl will take the electrons. Also 2 hydrogen atoms are present with this carbon. 1 with this, 3 with this, 2 with this and 3 with this carbon. The intermediate form will be like this. We have CH2. Chlorine bond is being broken. CN bond is being formed. We have CH, CH3, CH2 and CH3. Now we have 1 chlorine atom bonded to this carbon, 2 hydrogen atoms, 1 CN and 1 is this alkyl group. Let's look at the transition states. In A we have 2 hydrogen atoms, 1 CN, 1 chlorine and a group of alkyl in which second carbon has CH3. In B we have Cl, Cn and 2 CH3 attached, which are actually wrong. In C we have carbocation being formed. In D again we have a carbocation being formed, which is incorrect. So the only correct option is A. Question number 24. Propane 1-ol can be reacted with acidified potassium dichromate 6 to form propanoic acid, reaction 1, or propanol, reaction 2. These are the chemical reactions. How can the reaction be carried out to ensure that reaction 2 occurs rather than reaction 1? We can see that the center one is alcohol as it has OH group attached. In reaction 2, aldehyde is being formed from alcohol. This is aldehyde functional group. In reaction 1, we can see that alcohol is being converted into carboxylic acid functional group. Now generally we know that primary alcohol, when oxidized, upon oxidation it forms aldehyde, and if further oxidation takes place, then carboxylic acid is formed. Let's move towards the options. A. An excess of acidified potassium dichromate 6 is used, as it is an oxidizing agent, so it will oxidize alcohol to aldehyde and aldehyde to carboxylic acid. In the question it says that how can we ensure that only reaction 2 occurs rather than reaction 1? So we have to stop the oxidation at aldehyde and further oxidation should not occur. In B, we can see an excess of concentrated sulfuric acid is added. Again, concentrated sulfuric acid is also a powerful oxidizing agent. So both these will result in the oxidation of alcohol to aldehyde and aldehyde to carboxylic acid. So therefore, A and B is incorrect. C. The reaction mixture is distilled immediately after mixing. So what will happen that as soon as aldehyde is formed, the mixture will be distilled immediately and aldehyde will be separated out. So further oxidation won't take place, so this is the possible option. D. The reaction mixture is heated under reflux. As we know that under reflux full oxidation takes place, so alcohol will oxidize to aldehyde and aldehyde will further oxidize to carboxylic acid. So this is also incorrect. Therefore, the only correct option is C. Question 25. What is the smallest amount of oxygen molecules needed for the complete combustion of 40 grams of methanol? Let's write the balanced chemical equation for combustion of methanol. We have CH3OH. It reacts in the presence of oxygen to form carbon dioxide and water. Let's balance. The number of carbon atoms are already balanced, one on the reactant side, one on the product side. We have 4 hydrogen atoms with methanol and 2 hydrogen atoms in H2O, so we can write 2 with H2O. Now we have 4 oxygen atoms on the product side and 3 oxygen atoms on the reactant side. So we can write 3 by 2 with oxygen and 2 will cancel out with 2. 3 atoms of oxygen and 1 atom of oxygen will become 4. So we can see that the molar ratio between methanol and oxygen is 1:1.5 moles. In the question they have given 40 grams of methanol, so let's find out its number of moles. The molecular mass of methanol is 32. As moles is equal to mass in grams divided by molecular mass, and mass in grams is given, it is 40. Molecular mass is 32. So the number of moles will be equal to 1.25 moles of methanol. So we can see that 1 mole of methanol requires 1.5 moles of oxygen for complete combustion. So 1.25 moles of methanol will require X moles of oxygen. So by cross multiplying we can find out the amount of oxygen. So X will be equal to 1.25 into 1.5 moles. So it comes equal to 1.875 moles of oxygen molecules. So this corresponds to A in the given option, so therefore answer is A. Question 26. Compound X has stereoisomers and forms a precipitate when warmed with Fehling's reagent. What could be the structure of compound X? Now stereoisomers means there are two types of isomers. One is cis-trans isomer, and cis-trans requires the presence of double bond between two carbon atoms. Second stereoisomer is optical isomer, and optical isomer will require chiral center. Now compound X gives a precipitate with Fehling's reagent. It means that compound X is an aldehyde because aldehyde gives positive result with Fehling's reagent. The functional group of aldehyde is RC double bond OH. Let's first find out the functional group given in the options. In A we have RC double bond OH. As on this carbon one atom is H, so therefore this is an aldehyde functional group. On second option B we can see that carbon is present and it has two alkyl groups directly attached with this carbon, so therefore it is ketone functional group. Third one is also ketone. In D again we have aldehyde functional group present. So according to the question, the answer could be part A or part D. Now let's find out stereoisomers. In A we have double bond present, so therefore cis-trans isomerism could be present. For cis-trans, the rule is that the atoms or groups attached with the carbon atom that is making a double bond must be different. So we can see this is methyl and this is also methyl, and both are same groups attached with this carbon, so therefore compound A will not show cis-trans isomerism. Furthermore, we cannot find any carbon atoms that is attached to four different groups or elements, so therefore no chiral center is present. So therefore it won't show optical isomerism. Let's move towards D. In D we do not have any double bond between two carbon atoms, so it won't show any cis-trans, so no cis-trans is possible. Now let's find the chiral carbon. This carbon is attached with 3 hydrogen atoms, so this is not chiral. This carbon is attached to 2 hydrogen atoms, so therefore again this is not chiral. This is also attached to 2 hydrogen atoms, so not chiral. This one is attached with 1 hydrogen atom, 1 methyl group, one is this group that is attached, and one is carbonyl carbon functional group. So therefore this carbon is, so whenever chiral carbon is present, it shows optical isomerism. So in D we have aldehyde functional group which will give a precipitate with Fehling's reagent. Also we have a chiral carbon which will show stereoisomers. So option D is the correct one. Question 27. The diagram shows the structure of Y. Two suggestions are made about Y. Number 1. Y can be oxidized by hot acidified dichromate 6 ions. Number 2. 1 mole of Y gives 1 mole of tri-iodomethane when it reacts with an excess of alkaline aqueous iodine. Which suggestions are correct? Let's look at the diagram of the structure of Y. We have carbonyl carbons. Again we have another carbonyl carbon, so it is a ketone. Now looking into suggestions, we have Y can be oxidized by hot acidified dichromate 6 ions. as we know that ketone is not oxidized by this oxidizing agent. So therefore option 1 is incorrect. Second suggestion is that 1 mole of Y gives 1 mole of triiodomethane. So it gives positive triiodomethane result. Now we know that for positive triiodomethane result, CH3 C double bond O must be present. If there is no CH3 directly attached with carbonyl carbon, then triiodomethane result will not be positive. Let's look into the structure of Y. We have CH3, then carbonyl carbon, then CH2, again carbonyl carbon, then CH3. So we can see that CH3 is directly attached with the carbonyl carbon on one side and same is attached with carbonyl carbon on the other side. So one compound of Y will give 2 CHI3 products. So 1 mole of Y will give 2 moles of triiodomethane. So it means both suggestion 1 and suggestion 2 is wrong. So therefore option D is correct. Question 28. Esters can be prepared by the reaction of carboxylic acid with an alcohol in the presence of concentrated sulfuric acid. Which row gives the correct names of the reagents that would be suitable to prepare ester Z? Let's break down compound Z into carboxylic acid and alcohol. So this compound will break from this place, and the first portion is carboxylic acid, while the second portion is alcohol. Let's find out the number of carbon atoms in carboxylic acid. We have 1, 2, 3, 4. 4 carbon atoms with carboxylic acid. So 4 carbon carboxylic acid is butanoic acid. So it could be B or C. Second part is alcohol. Let's find the number of carbons present in alcohol. We have 1, 2 and 3. On second carbon atom, OH functional group will be attached. So therefore this alcohol consists of 3 carbon atoms. So it would be like this: CH3, CH, CH3, OH. So we have 3 carbon atoms in the long chain, so it is propane. And on second carbon atom we have alcohol functional group attached, so it is 2-ol. So therefore this one is correct. So answer is C. Question 29. Compound Q can be hydrolyzed by acid HCl. The two products of this hydrolysis have the same empirical formula. What could Q be? You should remember that whenever esters are hydrolyzed in the presence of acid, they form carboxylic acid and alcohol functional groups. In A we have ester compound, in B we have ester compound, in C we have ester compound, in D we have 2 OH groups attached, so it is alcohol. Let's find out the products after hydrolysis. So in A the structure will be carbon, then carbon, double bond oxygen, oxygen, then CH2, then CH2, OH. Now after acid hydrolysis, this compound will break from this place and first half will become carboxylic acid and second half will become alcohol. So the products are carbon, C double bond O, OH, and the alcohol formed will be, as this OH was attached previously, so a new alcohol functional group will also attach with this carbon atom. This will become like this. Let's put the number of hydrogen atoms. We have 3 hydrogen with this carbon, 2 hydrogen with this carbon, 2 with this. Now the molecular formula will be C2H4O2 for this compound and C2H6O2 for this one. So the empirical formula is CH2O, and for this alcohol we have CH3OS empirical formula. So empirical formulas are different, so therefore A is incorrect. Now let's look at B. We have carbon, then carbon with oxygen, then CH2, then carbon with carboxylic acid. Now this compound will break from this part after hydrolysis, and this side will become alcohol and the first side will become carboxylic acid. Let's draw the products. We have carbon, C double bond O, OH for the first part, and OH functional group will be attached with the first carbon atom in second part. Let's put hydrogen atoms. We have 3 hydrogens, 2 hydrogen, 2. Now the molecular formula of this compound is C2H4O2, and for this compound the molecular formula is C3H6O3. Let's find the empirical formula for C2H4O2. The simplified version will be CH2O. For C3H6O3, the simplified version will be CH2O. As we can see that the empirical formula is same for both the products, so therefore B could be the possible option. Let's look at part C. We have carbon, then ester functional group, then carbon, and CH3. So this will break from this part after acid hydrolysis. The products formed are C double bond O, OH for carboxylic acid, and OH with first carbon atom for alcohol. The number of hydrogen atoms are 3, 2, 2, 2, and 3. The molecular formulas will be C3H6O2 for this carboxylic acid and C3H8O for this one. Now the empirical formula will be the same because it cannot be simplified any further. As we can see that the empirical formulas are different for both of them, so therefore C is also incorrect. In part D we can see that alcohol is present, so therefore when alcohol is hydrolyzed by HCl, it does not give any product. So the only correct option is B. Question 30. Substance T was analyzed and found out to contain 62.07% carbon, 10.34% hydrogen, and 27.59% oxygen. The infrared spectrum of substance T is shown. As they have given the percentages of carbon, hydrogen, and oxygen, so we can utilize these values to find out the empirical formula. And also from looking at the infrared spectrum, we can find out the functional group present. As there is no peak in this region, so it means that carbonyl carbon is absent. And as there is a sharp peak from 3200 to 3600, so therefore this sharp peak could belong to alcohol functional group. Which substance could be T? So we have 4 options A, B, C and D. In A we have alcohol functional group, so this is alcohol and this is also alcohol, so it can give sharp peak between 3200 to 3600 per centimeter. In B we have carbonyl carbon, which gives a peak at 1680 to 1730 sharp, and also OH group, which gives a peak between 2500 to 3000 per centimeter. In C we have ketone present, and the carbonyl carbon of ketone will give a sharp peak between 1670 to 1740 per centimeter. And in D we have alcohol functional groups. So this OH and this OH will give a peak between 3200 and 3600 per centimeter, and it will also be sharp. From looking at the spectrum given, we can see that carbonyl carbon is absent, so therefore B and C are incorrect. So the answer could be A or D. Now let's find out the molecular and empirical formula of A and D. For A we have 1, 2, 3, 4, 5, 6 carbon atoms, so C6, and with these carbon there are 2 hydrogen atoms present, and with this carbon there is 1, and with this carbon there is 1 hydrogen atom. So in total there are 12 hydrogen atoms and only 2 oxygen atoms. So the empirical formula of A will be C3H6O. Now for option D we have 1, 2, 3, 4, 5, 6 carbon atoms. So the molecular formula is C6. Then we have 2, 4, 6, 8, 10, 12, 13 and 14 hydrogen atoms. And there are again 2 oxygen atoms. So the empirical formula will be C3H7O. Now let's find out the empirical formula from the values given in the question. We have carbon, hydrogen and oxygen. Carbon is 62.07%, hydrogen is 10.34%, and oxygen is 27.59% present. In the first step, we have to find the number of moles, as mole is equal to mass in grams divided by molecular mass. So we can take these percentage values as mass in grams. So it would be 62.07 divided by atomic mass of carbon, which is 12, 10.34% divided by atomic mass of hydrogen, which is 1, and 27.59% in grams divided by atomic mass of oxygen, which is 16. So the number of moles will be 5.1725 for carbon, 10.34 for hydrogen, and 1.7243 for oxygen. Now we can simplify these values of moles by dividing with the smallest value. We have 1.7243, which is divided on all 3 sides. Now the simplified ratios are 3, 6 and 1. It means the empirical formula is C3H6O1. So this corresponds to option A. So therefore answer is A. Question 31. Which gaseous molecules are polar? First is ammonia. The structure of ammonia is NH3, where nitrogen is more electronegative than hydrogen, and also there is a lone pair of electrons present on nitrogen atom. The structure of this molecule is trigonal pyramidal, so therefore it is polar. In option 2 we have hydrogen sulfide. Sulfur belongs to group 6 in the periodic table, so it has 6 electrons in the outermost shell, out of which 2 electrons are bonded with 2 hydrogen atoms and 2 lone pairs are also present. As sulfur is more electronegative, so therefore it would have partial negative charge and a hydrogen would have partial positive charge. The structure of H2S is like water. It is also bent structure and this is polar in nature. Third compound is BF3. Boron has 3 electrons in the outermost shell and it forms 3 single covalent bonds with 3 fluorine atoms. The bond angle is 120 for each bond and the structure is trigonal planar. Fluorine is very electronegative element, so it would have partial negative charge. As we can see that there is equal distribution of or you can say even distribution of bonds around the central atom. So therefore net dipole will be equal to 0. Therefore this BF3 compound is non-polar. In first two we have unequal or unsymmetric distribution of electrons around the central atoms, therefore they are polar in nature. So option 1 and 2 are correct, so therefore answer is B. Question 32. A carbon monoxide molecule CO has 3 bonds between carbon atom and oxygen atom. Which feature are present in one CO molecule? Now carbon belongs to group 4 in the periodic table and oxygen belongs to group 6 in the periodic table. So therefore carbon has 4 electrons in the outermost shell while oxygen has 6 electrons. Out of these 6 electrons of oxygen, 2 are making double covalent bond with carbon while 4 are left behind. Now let's look at the octet. We can see that carbon atom has 6 electrons in total, so therefore its octet is incomplete. While in oxygen atom we can see that there are 8 electrons present, so therefore its octet is complete. So now what will happen, that oxygen will donate its lone pair of electron to carbon atom to make a coordinate covalent bond so that the octet of carbon also becomes complete. So we can draw the structure of carbon and oxygen like this. We have 2 covalent bonds, 1 coordinate covalent bond between carbon and oxygen. 1 lone pair is left on oxygen atom, this one, and 1 lone pair is on carbon atom. Let's look at the options. In 1 we have 2 lone pairs of electrons. This is correct because 1 lone pair is present on carbon, 1 lone pair is present on oxygen. Number 2, a coordinate or dative covalent bond from oxygen to carbon atom is present. As we can see that oxygen has donated its lone pair to carbon atom, so therefore option 2 is also correct. In option 3 there are 2 pi bonds. As we can see in the structure that 1 sigma bond is present and 2 pi bonds are present, so therefore 3 is also correct. As all options 1, 2 and 3 are correct, so therefore answer is A. Question 33. Carbon can exist as allotropes which include graphite, diamond and a fullerene. Which statements are correct? Option 1. All 3 allotropes contain covalent bonds. We can see that in graphite carbon makes 3 covalent bonds with 3 other carbon atoms. In diamond what happens that carbon makes 4 single covalent bonds with the other carbon atoms. In fullerene the bonds are similar to graphite and carbon makes 3 covalent bonds with other carbon atoms. As carbon is a nonmetal and nonmetal makes covalent bonds, therefore option 1 is correct. Option 2, all 3 allotropes are giant molecular. We can see that graphite is giant molecular, diamond is also giant molecular, but fullerene is a small molecules made up of almost 60 carbon atoms. So therefore option 2 is incorrect. Option 3, all 3 allotropes have delocalized electrons. We can see in the structure of graphite, carbon makes 3 covalent bonds, and also in fullerene, carbon makes 3 covalent bonds, and the 4th electron of carbon is free to move, so therefore in graphite and fullerene, we have delocalized electrons. But in diamond, what happens that all 4 electrons of carbon are involved in covalent bonding, so therefore no free electron is present. So diamond does not have any delocalized electrons. So option 3 is also incorrect. So only one option is correct, so therefore answer is D. Question 34. The reaction pathway diagram for a reversible reaction is shown. We have this diagram. On x-axis we have the progress of reaction and on y-axis we have energy in kilojoules per mole. Which statements are correct? 1. The enthalpy change for the backward reaction is negative 20 kilojoules per mole. As we can see, this is the product and this is the reactant. The enthalpy change is the energy difference between products and reactants. As we can see, product has more energy as compared to the energy of reactant, so therefore backward enthalpy is negative, and they have given the difference which is 20, so therefore it would be minus 20 kilojoules per mole. So option 1 is correct. In option 2, the forward reaction is endothermic. Endothermic means that the energy is being absorbed. As we can see that the energy of reactant is lower than the energy of product, so it means that reactants have absorbed energy in this chemical reaction, so therefore the energy of product is higher, so therefore this is correct option. Third option, the activation energy for the forward reaction is plus 70 kilojoules per mole. Activation energy is the energy required by the reactants to convert into transition state. So as we know that 50 plus 20 will be the total activation energy. So 50 and 20 is equal to 70. As the arrow is upwards and reactants absorb energy in order to get into the transition state, so therefore it is plus 70 kilojoules per mole. So this is also correct. All three options are correct, so therefore answer is A. Question 35. Silicon forms a tetrachloride SiCl4. Which statements are correct? Let's draw the structure of SiCl4. Silicon belongs to group 4 in the periodic table, so it has 4 electrons in the outermost shell. 4 single covalent bonds are formed between silicon and chlorine, so we have 4 chlorine atoms attached with 1 silicon atom. Let's move towards the options. In 1, it says in SiCl4 the silicon is partial positive and each chlorine is partial negative. As we can see that chlorine is more electronegative as compared to silicon, so therefore chlorine would have partial negative charge and silicon would have partial positive charge. But we can see that there is symmetric distribution of electrons around the central atom, so therefore overall there will be no dipole present, and overall this molecule will be non-polar. So as partial positive and partial negative charges are present, so option 1 is correct. In option 2, it says silicon chloride is a liquid at room temperature. Now silicon chloride is a volatile liquid, as only van der Waals forces of attraction are present between SiCl4 molecules, so therefore option 2 is also correct. Option 3, silicon chloride reacts with water to give an acidic solution and a precipitate. Let's write the chemical equation for this reaction. We have SiCl4 in liquid form. It reacts with water to form SiO2, which is solid, and also HCl in the form of gas. As we have 4 chlorine atoms in SiCl4, so we can balance by writing 4 HCl. Now we have 4 hydrogen atoms on the product side, so we can write 2 with hydrogen. Now the equation is balanced. As we can see that SiO2 is formed, which is a precipitate in solid form, and HCl gas is formed, which is acidic gas, and it will give acidic solution when dissolved in H2O. So it will form H plus ions and Cl negative ions. So option 3 is also correct. As 1, 2 and 3 all are correct, so therefore answer is A. Question 36. Which statements about ammonia are correct? Option 1. An ammonia molecule has 3 bond pairs and 1 lone pair of electrons. For these options we can draw the structure of ammonia. Nitrogen belongs to group 5 in the periodic table, out of which 3 electrons make 3 single bonds with hydrogen and 1 lone pair is also present. So we have 3 bond pairs of nitrogen with hydrogen and 1 lone pair, so therefore option 1 is correct. Option 2. When ammonia is bubbled into water, the pH of solution increases. Let's write equation for this reaction. We have ammonia. When it is dissolved in water, what happens that it becomes ammonium hydroxide. Now ammonium hydroxide is basic in nature because it forms OH negative ions. So therefore, because of the increase in OH negative ions, what happens that pH of solution will become more basic or it will increase. So option 2 is also correct. In option 3, ammonia gas can be made by warming ammonium sulfate with aqueous hydrochloric acid. Let's write equation for this reaction. We have ammonium sulfate. It reacts with aqueous HCl to form ammonium chloride and sulfuric acid. As we can see that no ammonia gas is formed. Actually, whenever we need to make ammonia gas from ammonium salt, we would take ammonium sulfate and react it with alkalis such as sodium hydroxide. Now it will form salt Na2SO4 along with ammonia and water molecules. So therefore option 3 is incorrect. As option 1 and 2 are correct, so therefore answer is B. Question 37. Following fractional distillation of crude oil, which processes can be used to produce propene from larger hydrocarbon molecules? Option 1 is cracking. Now we know that in cracking what happens that large hydrocarbon molecules are broken down into smaller, lighter hydrocarbons. As propene is a compound having 3 carbon atoms and 6 hydrogen atoms, so therefore this is also a smaller and lighter hydrocarbons, so it could be made from cracking. So option 1 is correct. Option 2 is reduction. Now what happens in reduction that we add hydrogen. Now whenever hydrogen is added, what happens that the double bonds that are formed will convert into single bonds, as hydrogen is added to unsaturated hydrocarbons to make them saturated. In alkene we have 2 hydrogens, 1 hydrogen and 3 hydrogen atoms. When reduction will take place, what will happen that CH2 will become CH3 and CH will become CH2. So therefore propene cannot be produced by reduction. Third option is polymerization. What happens in polymerization? For example, if we have alkene molecule, then addition polymerization will occur and double bond is converted into single covalent bond. So therefore propene will not be formed and long chains of larger hydrocarbons are produced. So therefore option 3 is also incorrect. As only option 1 is correct, so therefore answer is D. Question 38. Bromoethane undergoes nucleophilic substitution reactions. Which statements are correct? Now the general equation for nucleophilic substitution reaction for bromoethane could be written like this. We have 2 carbon atoms for bromoethane and Br is also attached. As bromine is partial negative and carbon is partial positive, so therefore nucleophile having lone pair of electron or negative charge will attack on this partial positive carbon and bromine will take electrons from this bond. So the product formed is like this. We have nucleophile being attached with carbon atom and bromine atom is removed in the form of negative ion. Let's look into the options. In option 1, bromoethane reacts with aqueous sodium hydroxide to make ethanol. So the reaction will be similar to as the one given. We have bromoethane and it will react with aqueous OH. What will happen that OH will be attached with carbon atom and bromine will be removed in the form of negative ion. As 2 carbon OH is ethanol, so therefore option 1 is correct. Option 2, bromoethane reacts with ethanolic NH3 to make ethylamine. Let's look into this reaction. We have two carbon atoms, one bromine, partial negative for bromine, partial positive for carbon. We have ammonia, NH3. With nitrogen having lone pair of electrons, it will attack on partial positive carbon. This bond will be removed. Now the product formed is two carbon atoms with nitrogen, and one of the hydrogen atom will be removed from nitrogen because nitrogen can make only 3 covalent bonds. So the hydrogen atom from ammonia and Br from bromoethane will form HBr molecule. Now the product formed is like this. We have CH3, 3 hydrogen atom with first carbon, then CH2, 2 hydrogen atoms with second carbon, then we have NH2. So whenever NH2 is present with alkyl group, the name is ethylamine. So option 2 is also correct. Option 3, bromoethane reacts with ethanolic KCN to make ethane nitrile. Let's write equation for this reaction. We have bromoethane, as KCN will produce K plus and CN negative, and there is a lone pair present on cyanide, so therefore it will attack partial positive carbon. The product formed will be like this. We have Cn attached with carbon atom, and Br will be removed in the form of negative ion. We can write this product as CH3, as there are 3 hydrogen atoms with this carbon, then CH2, as 2 hydrogen atoms are with this carbon, and then we have triple bond between carbon and nitrogen, so it will be Cn. Now let's name this compound. We have 1, 2, 3 carbon atoms, and nitrogen is triple bonded with one of the carbon atoms, so it is propane nitrile. As propane nitrile is formed instead of ethane nitrile, so therefore this option is incorrect. So option 1 and 2 are correct, so therefore answer is B. Question 39. Which reagents when used in excess can convert Y into Z? We can see in Y we have alcohol functional group, also we have carboxylic acid functional group. The alcohol functional group remains intact and carboxylic acid functional groups turns into a salt. First is sodium metal. As we know that sodium metal is reactive, so it will react with both alcohol functional group and also with carboxylic acid functional group. So the products of Y with sodium will be like this. We have CH3, then CH, OH that was attached with CH will convert into alkoxide having sodium and oxygen, and CO2H will convert into salt of sodium. So option 1 is incorrect. Option 2 is sodium carbonate. Now as we know that carbonate reacts with acid to form salt, water and carbon dioxide. Let's draw for this structure. We have CO2H plus Na2CO3. The product form will be CH3, CH, OH, CO2Na. Now this is the sodium salt of this compound Y plus CO2 gas plus water molecules will be formed. As we can see that this product corresponds to compound Z, so therefore option 2 is correct. For third we have sodium hydroxide. Now sodium hydroxide is alkali and alkali reacts with carboxylic acid functional group to form salt and water. We can write this reaction as NaOH. It will give sodium salt of this reactant along with H2O. So as this structure is also like compound Z, so therefore option 3 is also correct. So as both option 2 and 3 are correct, so therefore answer is C. Question 40. Each of the compounds below is treated separately with excess of NaBH4. The product of each reaction is then heated with an excess of concentrated H2SO4. Which compounds give only one final product with the molecular formula C7H10? Now you should know that NaBH4 is a reducing agent. And concentrated H2SO4 is used as a dehydrating agent, so it will remove water. Let's look into the options. In option 1 we have carbonyl carbon, which have two carbons directly attached, so it is ketone. Second is carbonyl carbon with hydrogen attached, so this is aldehyde. In option 2 again we have a ketone functional group, and second functional group is aldehyde. In option 3 again we have a ketone functional group, and second is aldehyde. Now as a general reaction we know that aldehyde reduces into primary alcohol, and when dehydration of primary alcohol occurs, it forms alkene. For ketone, we can say that whenever reduction of ketone occurs, it converts into secondary alcohol, and secondary alcohol upon dehydration will give alkene. Now let's look at the detailed reactions of 1, 2 and 3, first with NaBH4 and second with concentrated sulfuric acid. Number 1. This is the first compound. Now the first reaction is with NaBH4, which is a reducing agent, and this compound will be reduced. Ketone will be reduced into alcohol functional group OH, and aldehyde is reduced to primary alcohol functional group. Now second reaction is with H2SO4 and dehydration will occur. Now in dehydration water molecule is removed, so from one carbon we have OH being removed, and from adjacent carbon, which could be this one or this one, hydrogen atom will also be removed. Similarly, OH from this carbon atom is removed, and hydrogen atom from adjacent carbon, which is this one, will be removed. So therefore two different types of products are formed. One is we could have double bond between these two carbon atoms and between these two carbon atoms, or the double bond could be between these two carbons. Let's find the molecular formula of the product. We have 1, 2, 3, 4, 5, 6, 7 carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. For second structure again we have 7 carbons and 10 hydrogens. Now these two compounds are different because the position of this double bond is changed. For second compound we have carbonyl carbon on this carbon atom. First reaction will be reduction in the presence of NaBH4, and ketone is reduced to secondary alcohol OH, and aldehyde is reduced to primary alcohol functional group. Second reaction is the removal of H2O. So OH will be removed from this carbon and hydrogen atom can be removed from adjacent carbon, which could be this one or this one. Similarly, OH is removed from this carbon and hydrogen will be removed from this carbon atom. The structure of product will be either the carbon double bond will be between these carbons, or the double bond could be between these two carbon atoms. Let's find the position of double bond by numbering carbons. We have 1, 2, 3, 4, 5. So the double bond is between 4th and 5th carbon atom. In second structure we have 1, 2, 3, 4, 5. Now the double bond is again between 4th and 5th carbon atom. So therefore these are same compounds. Finding the molecular formula, we have 1, 2, 3, 4, 5, 6, 7 carbons and 10 hydrogen atoms. As this one is also same, so we have C7 and H10. As both the products are same, so therefore it will be considered as one single product. Moving towards option 3, we have this structure where carbonyl carbon is present on this carbon and on this carbon. First reaction is reduction. Ketone will be converted into secondary alcohol and aldehyde is converted into primary alcohol. In second step, dehydration will occur in the presence of sulfuric acid. And we can see that in this structure, OH group from this carbon atom is removed and hydrogen atom from this carbon atom will be removed to form one water molecule. And then for this OH, we have hydrogen atom present on this carbon which will be removed. So two double bonds will come, one between these two carbons and second between these two carbon atoms. Let's draw the product. We have double bond between these two carbons and also double bond between these two carbon atoms. So only one product is formed. Let's find the molecular formula. We have 1, 2, 3, 4, 5, 6, 7 carbons. Ten hydrogen atoms. So we can see that compound 2 and compound 3 give only one possible product and compound 1 gives two different products. So therefore option 2 and 3 are correct. So therefore answer is C.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy
and enjoy learning.